if your phone will allow it, will access the slides that I'm going to show. Because there is a lot of screenshots and the writing is very small. So I will read it, and you'll have this anyway afterwards. You can explore it. So that's why that's there. So has everyone that wants it got it? Yeah. Right. So yeah. So this talk actually is not slightly different, making developers happy, and kind of the reason for making this talk is I have over the last 12 months been spending a lot of time getting hands-on with this new thing that everyone is talking about. And in my job, I talk to developers, talk to people about tech, and so now I have put together my thoughts on this. So really the idea here is to try and expose really kind of like some of the myths, give you an understanding of how as software developers these tools can be useful. But I guess first of all, how many of you identify as developers? A few, yeah? How many of you identify as managing developers? Right, okay, a few more, right. So if you're technical, I think this talk, if you're involved in developers, I'll try and stay in the zone, then this talk is going to be of interest. So the first thing is, as developers, what is your most favourite thing that you do? So I want people to tell me what they think. Just shout out what you think as a developer your favourite part of the job is.
Solve problems.
Okay, who said that? Solve problems. That was the first thing I had as well. Architecture. Okay, architecture. Creativity. Yep. Okay. Any others?
Not making people happy.
Oh, that's good. I like the segue there into the talk. Yeah. How do you make people happy as a software developer?
Give them good solutions.
Give them good solutions, right?
Solutions that help their day-to-day lives.
Right. Okay. Alex, what about you? What makes you a happy developer?
When people don't shout at me.
Oh, okay. That's an interesting one. That's an interesting one. A lack of throwing objects in my general direction. Okay. But as a whole, if you identify as a developer, there are things about the job that you do like, right? Problem solving was the thing that I put first because that's the thing that I love. Creativity is also the thing I love about a software developer. But you can't have good things without bad things, right? So what are the less favourite things about this? Who wants to put their... People, did I say people?
Customers, colleagues.
Customers.
Messy requirements.
Sorry?
Messy requirements.
Messy requirements. Okay, yeah, scope creep, messy requirements. People don't really know what they want. What else? What else do people work?
Tests. Writing tests.
No, I'm not a fan of test-driven development then.
Well, no, I'm a fan of it in principle. It's in
Yeah,
practice.
okay, right. Okay, so writing tests. So are there parts of the developer job that people like to do less? So tests obviously one. What about, there must be something else, right? So when you're doing a project, what are the things that you dread that you're told to do, that you kind of try? Sorry?
Legacy code.
Lazy code.
Legacy.
Oh, legacy, okay,
Yeah.
like it.
Stuff you did right.
Okay, yeah, legacy code. Sorry, did someone say?
It's the writing documentation.
Writing documentation. God, you are all playing into my game here, which is fantastic. But yeah, there are things, right? There are a lot of things that we do that we don't really want to spend a lot of time because we want to spend time doing all the other stuff, right? At least that's me anyway. But in reality, when you're working on a project, how much time do you actually spend doing the coding? Anyone want to hazard a guess? 10%. 10%? Wow, that's low.
Just remember, there's a security guy here who's asking to do security.
Actually, I'm surprised no one said there's the things they don't like doing. Security, actually. Yeah, that was interesting, right? So that must mean either they don't hate it, but they don't love it either, right? So anyone has it? So think about the time you spend doing development. How much, as a percentage, would you say you're doing actually hands-on coding? Not much. God, that is low. No wonder your customers are unhappy and shouting.
30 to 40%.
I would say over 50% of my time.
50%. Wow, you are a power developer.
It's called working from home.
Yeah.
It means you can hide from people.
Yeah. So the reality actually is, I think it's, according to Gartner, if you believe Gartner, it's only 27, it's either 27 or 37% of the time developers actually spend hands on keyboard, writing code to solve the problems that they've been given to help the business. So it's not actually that much time. So what else then? If we're not coding, what are we doing? Oh, okay, learning.
Meetings.
Yes.
Okay, but what are we doing in those meetings? Well, we've got a cynical one here. We've got a cynical one here. But I don't disagree with you. Having worked in the corporate world, that is definitely something I recognise. But what else are we doing in meetings? Thinking.
About how to code.
Thinking about how to go. It's kind of learning as well. Yeah, okay, all right. So we think, we ponder. Sorry? Politics. Okay, but from a less politics stuff, what from a technical, from an actually kind of like practitioner perspective, what are the things that, in order to get the job done, what else are we doing that's not coding? Requirements, someone else says something? Collaborating, so discussing the requirements. Okay. Firefighting. Solving problems, other people's problems, taking on work. Sorry? Dividing work. Okay, this is all good stuff. So in effect, this is what we're doing, right? So we don't actually do... Are people familiar with this? The software development lifecycle. So whenever we write code to solve a problem, we have this process that you do invisibly and you do it repeatedly, right? So we work from understanding the problem to coming up with designs to actually writing the code, testing it, deploying it, and probably not so much the maintaining bit, right? And we do it once, then we do it again and again and again. And so there are different flavours of this. People put different words on it. These are just my words, but they're kind of pretty much the ones that you would expect. And so this is actually this kind of takes up the whole time that developers do. So we're only spending a fraction of the time in the middle there developing, and we're doing all the other bits and pieces in order to make the stuff that we want to give to our customers. Oh, what's going on? It's not working. Oh, okay, right. So you can't have a talk without a Yoda quote. And the reason for this quote is that my computer is obviously not... here we go. I'm not actually quite sure why my computer is doing this. This is strange. So if we look back in the past, right, at developer productivity on the left-hand side, and I guess time, it's not abstraction, it's time on the right-hand side. Since the beginning of kind of tech, of computing programming from Ada Lovelace onwards, we've effectively improved the ability to produce code by increasing the levels of abstraction, right? You know, when I started back in kind of the 80s, I was writing assembler on my Commodore 64, right? Because that's the only way you could really do anything with the Commodore 64, right? But now, people who start wouldn't even dream of going and learning assembler, right? You learn, probably the lowest level people will do is C and C++, right? Most people are doing interpreted languages like Python or JavaScript. And the reason for that is as we've gone up this path, we've effectively made it easier to actually access machines, and then we've made it easier for more people to actually do the development. And that kind of also happens with the tools. I mean, I remember a time when there were no such things as IDEs, and we had various kind of text tools that allow you to kind of cobble the code together and compile it. And in my lifetime, this is not an exhaustive list. This is what I've seen. Okay, and we've got to a situation where now, actually, as a developer, we've got so much stuff that actually helps us. And so when we look at the actual kind of background of technology plus the tools, and then actually where we actually are operating. I mean, I worked pre-internet. CompuServe BBSs were my entry point. Then we had the internet. Then we had, Alta Vista and Google Search. And Google Search really was kind of the big moment where suddenly all this information became available. And then because of that, and because of the growth of the internet, we then had these sites like Stack Overflow, Reddit, that kind of created kind of like condensed forms of information that serve different communities, including developers. And so what this led to, and so this is, so graphic designers, your job is safe. I asked Stable Diffusion, create a keyboard with 3 keys, Control, C, and V, and that's what it gave me, right? So I think our jobs are safe. If you're a graphic designer, you don't have a problem. But you've all seen the meme, okay, where effectively developers have become Control C, Control V jockeys. We have a problem, or we want to write some code, we find it somewhere, Control C, put it into our project, Control V, and that's kind of like half of the job we do now, okay? But there has got to be a better way, right? First of all, before I kind of carry on, who relates to the copy C, copy V? Who here does it? I do it. I'll put my hand up. Is there anyone who doesn't do it? Wow. So you're...
Because I'm learning, so I want to try and,
Okay.
not
do it. Well, okay, so you are lucky because you're probably about to enter the world where you don't actually need to do this anymore. So this is pretty interesting. But yeah, I mean, I know that I have spent the last probably 5-10 years when I'm coding, not exclusively, but certainly a good chunk of time copying other people's code, and obviously giving attribution as well. I work with open source, so attribution is key. But there's got to be a better way, and there is. Because when you think about it, I speak English, I speak Spanish, a bit of Portuguese, a bit of German, a bit of French, a bit of Python, a bit of Java. When you think about it, programming languages are languages, okay? So code can be thought of as language. And we've kind of like in this new world, right, of large language models. Now I actually, in this particular story or deck, I've not actually put the kind of origins of how these things got created. I can switch to that if people are interested in that, but this is kind of more a developer type thing. So the key thing here is that probably from about 5-6 years ago, when it's 2017, so it's more than 6-7 years ago, when the Google engineers who now went to DeepMind created the Transformer Attention is All You Need paper. The models and the way we trained them got better at working with and understanding language. And in this specific scenario, they were really focused in natural language processing. So they wanted better search, better understanding of search, so they could actually then create better search results for their customers. But what they found when they started then throwing huge amounts of data is they encountered that the way that the tool was working was very, very effective at understanding what the person wanted. And so we ended up in a situation where a combination of algorithms and huge amounts of data, plus the power of the cloud to train it all, ended up creating these large language models. And that's what effectively underpins this new kind of model of allowing us to write some words, and then the system, the large language model, understand it and then give us some output back. So anyway, that's a thing. So where we are now, okay, is we're in a situation where generative AI has become almost like the next evolution of developer tool. So when I have a problem, or if I'm starting a project, I used to go to Google and say, I want to start a Python project using Flask, I want to do authentication, and I want to access a Postgres database. And I'd get a whole bunch of results. I'd look through the code, make sure it was a license, an open source license, and then fork it and then use that as my basis, right? That's the old way. Now what I do is I go into my generative AI chat. I say, I need this, and it creates it for me. And it feels like magic. So first of all, who has tried these things here? Okay, so we've all tried them. Which ones have we tried? ChatGPT? Sorry? Bard, okay. Any other ones? Copilot? Right, so we've the main ones, right. So we have one, it's called Q. Actually, I can't say Q, I've got to say Amazon Q, we're not allowed to call it Q. For obvious reasons. So we're in a situation now where the craft of the developer is, I think, being reimagined. And I'm going to walk you through now, through the SDLC, how I, myself, this is a personal story, right? This is the stuff I'm doing. But, and so it's by no means a comprehensive, there are probably more things that people are doing with this, right? And I mention this is because the tools are not just when I'm doing development, okay? The tools are useful across the entire software development lifecycle. Make sure time-wise. I think I was going to do this talk in 2 parts, but I'm not sure. Well, I mean, I can still try and do it in 2 parts.
Well, you can choose where you want to start.
Yeah. Because the idea is to actually kind of go out of this and actually show you this in action, but some of you sound like you've already done this already. So the first part, in the analysis phase, what I have found it useful for is actually asking the large language model how to prepare for the analysis phase. So this might mean, how do I understand the domain space? So if it's a new technology area, if for example I'm working in, say, if I have to work on a mobile Flutter application, I might not know anything about Flutter. So I can start to ask questions. What do I need to know about Flutter? What are the top 3 things that people are doing with Flutter? What are the functional, non-functional requirements when building Flutter applications? So I can start to actually read this and build effectively more effective questions to go into meetings with my customers in the analysis phase. And so as a developer, rather than having to scrabble around and find this through Google search, I now just do this in my developer tools. The next stage, once you've actually had your conversation with your customer, you've refined your requirements, this is what these tools help you do, you can then go to the kind of the next stage, right? So here you're trying to convert the requirements into actual architecture designs. You're starting to select technologies, frameworks. You're starting to think about approaches. You're starting to think about how you're going to size this. One of the things that I've been using it for is I go to a customer and they say, you know, I want to scale this to 1 million users and we have about 100 million requests per hour. How do I need to size this? And you think, oh, that's quite a tough question, right? How do I even begin to approach that? And these tools actually have got pretty good starting answers or questions that you can use to work through. And so during the design phase, you can use them to again help you move from the it depends. Who uses it depends a lot in this phase? Everyone does, right? So it allows you to move from the it depends to a much more opinionated set of choices. It's not going to choose for you, but it's going to narrow down from 100 choices to maybe 3 or 4. We have this kind of running joke in AWS. There's 17 ways to deploy containers. There's 30 ways to deploy infrastructure. Which one do you use, right? And so these tools can now help you narrow down to one or two. And architects aren't actually left out. My colleague Dennis, he actually wrote a blog post about this, about how architects can use this. I was on a call before Christmas with Finos. Finos is the open source financial services group, part of the Linux Foundation. They have monthly get-togethers, and they are working, one of the banks is working on a tool that intakes all their kind of like enterprise architecture documents, guidance, rules, and then provides them with effectively a virtual architect that allows them to ask questions about is this the right architecture for this application based on their standards. It allows them to ask questions such as, if I want to refactor this application, what do I need to think about? So these are how these tools are helping architects with these kind of in these kind of phases. Really powerful stuff. But this is stuff that you have to put in, right? So so in that specific example, these are not going to be available on Copilot, on Bard, on even on Q, right? You have to build your own model for that. Well, not model. You have to build your own large language model application that sits on top of this, which I'm not going to talk about too much. Then we actually get to the fun bit, okay, and how these tools can help you actually accelerate. And one of the things that I'm finding these are very useful for is actually being able to quickly learn new things. Who here is a regex expert? Anyone? Exactly, yeah, exactly. No one, right? But they are essential, critical. You can't really code without knowing regex, right? So I can now use these tools to tell me, give me the regex for this, and it just gives it to me, right? I don't have to now go hunt for the regex online editor, and I mean, I still check it, but if I'm terrible at SQL, right? Absolutely terrible at SQL. Now I just use these. Say, tell me the SQL based on finding this information on these tables with this schema, and it just gives it to me. So it allows me to kind of quickly create code, understand new concepts without me having to leave my actual IDE. Who here creates bug-free code? No one, right? Exactly, yeah. You have to ask, because there might be that one person, that says, yeah, I never have any bugs. One of the, I think, really, really useful ways that I'm using this is I write code, and I'm very clumsy. I make typos, and I can just do Control-A, click on Fix, and it just fixes it for me. Right? It sees as a typo, it tells me whether there's a typo, and it's like another pair of eyes. Right? And that is so useful. If I get an error message, I could Google that like I used to, and then get to the Stack Overflow page, or I can let these new generative AI tools help me actually give me the fix there and there in my IDE. So as a developer, there's loads of ways these tools are being really, really useful, and I think really if you think about it, what they're really doing is they're kind of like reducing the context switching, so that I'm in my IDE, I can stay in my IDE, I don't have to go and look at anyone else. And actually, I was last week, I was looking at my Google search history, right, for the last sort of 6 months, and it's quite amazing that I'm just not doing any Google searches that hit things like Stack Overflow or Reddit, or even some of the websites I normally use, right? And it's had a really dramatic effect on my search history. So no wonder Google's worried. We mentioned testing. People don't like tests. So it's a common pattern, actually. No one likes tests, whether it's unit tests, integration tests, security tests, or even running testing tools on a command line. Okay, there's a whole bunch of stuff we have to do in testing to make sure our actual software works. Wouldn't it be nice if these tools could just look at our code and create the test for us? Well, the answer is they do. They do it with varying degrees of quality, and this is still very much a hot area, especially when it comes to unit tests, because there are different schools of thought. Do you write your test first and then write your code? Do you use generative AI to write your test and then, do you spend your time writing your test yourself and then use generative AI to generate the code? Or do you write the code and then use generative AI? Every week there seems to be a new person that's got a new view that says one way is better than the other. There's new emerging frameworks to actually test the quality of the tests that get produced. And also, if you're using generative AI, what we're doing now within Amazon is we're actually unit testing the actual language models themselves. So, we have a set of standard prompts, you put them through the system. If they're not giving you roughly the sort of similar kind of outputs, something's screwy with the model. So even down to that level as well. Then it actually comes to the deployment, because obviously, we've done the hard work now, we've tested the application, it's working. Now we need to deploy it. Even today, it still shocks me that people don't use Git to manage their application artifacts, source code. They don't use infrastructure as code to automate the deployments. It's still very manual. Documentation, which was mentioned as a toil job, is sketchy, both in the code but also outside the code. And these are all the kind of things you really need to do before you ship your application. And these are all things that I'm finding these tools really, really useful to do. And I can do all of this now in literally seconds. And I do have screenshots, so I'll show this. This all come to life, hopefully. And then the last bit, is once our application's going to go, we need to, maintain them. And this is, one of the when we talked about things that people hate doing, taking on legacy code bases is one of the things that most people do not like. Wouldn't it be nice if you could point these tools at Codebase and ask it, tell me about this application, what does it do? Well, guess what? They're really good at doing that, really good. And they're also really good at taking applications that are about to go end of life. So Java 8, I think end of life, so long-term support ends, I think, in June, this year. So everyone is trying to think about migrating to Java 17, but it's not a trivial upgrade. Wouldn't it be great if these tools could help you do that? I was speaking to one of my customers in Costa Rica. He said, it takes me, Rick, about a week normally to do it. He's been trying Q, one of the product we've got, and part of it's called Q Transform. And Q Transform migrates old Java to new Java. And he goes, I said, what took me a week now takes me 12 minutes. I said, it's fantastic. I said, how are you using extra time? I said, I just go to the coffee, I go for a coffee. I said, I go for a walk. I don't tell the business I'm taking less time, I'm just having more time to enjoy myself. I said, well, I'll keep that quiet if I was you. But these tools have got lots of promise. And whilst we're focusing on Java, we're working with an open source project called Open Rewrite. .NET is also on the cards. But if you think about it as applications you have, whether it's a library that's going out of date, maybe a security vulnerability, right, that comes with a library, and you need to change your application. These tools can help you effectively refactor the code, update the code more effectively. So here's a post from one of my colleagues, actually, how they used this to migrate from JavaScript to Java to Python. So that's kind of breaking down the different ways I'm finding these tools useful across the software development lifecycle. But the reality is that we don't follow the steps in the software developer lifecycle, right? What we do as developers, we have these developer journeys based on what we're doing. So one time I'll be building something new, other times I'll be having to maintain something, sometimes I'll be having to fix a bug that someone has told me to fix. So you can probably recognize that these are some of the activities that you're told to do or we do as developers. And so what's interesting is how you take this now into those. So what I'm going to go do now is show you how, and this is where you're not going to be able to see at the back, right? That's why I had the QR code, but I will talk you through it, right? So across the different, so imagine we're building a new application. So, yes.
So if people came in late, could you bring the code up again?
Yeah, of course. I can do that.
If anyone is on the Slack channel, I put it on there, but we've got a few newbies that might not be on there, so.
That is the QR code. So, is it not working from there? Yes.
Does everyone else get it?
Yeah. Right.
Do you use the Wi-Fi? Or do you got good networks?
So I'm hotspotting with Alex because mine didn't work.
Is everyone on hotspot on my phone?
No, you don't want to do that. Right. Right. So imagine you're a developer and you've been asked to build a new application, right? So in my fiction, I started this on Tuesday, right? Just to kind of go through the process, see how quick it would be, fit it around my meetings and all that kind of stuff. And in this particular example, the fictitious customer wants me to interact with an external system and grab data from it on a daily basis. Okay, so I can go into this, and in the analysis phase, I can use these tools to do requirements gathering to get a better understanding. So I can actually ask it, for this kind of application, what are the type of functional and non-functional requirements I need to think about? I can actually, if it's something I'm not aware of, I can actually try and get more information about the problem space, and I can actually now use this to kind of, rather than overthink things, narrow things down. So let's actually take a look at what this looks like. So this is where unfortunately you're going to struggle, right? So I will walk you through it, and I will explain what this is, right? So this is it's a generative AI chat application that we have built into the AWS console, but we've also built it into the ID. So I'll show you this in the second part, right? And I can ask it questions such as, I'm not familiar with working with GitHub. What do I need to know about if I'm going to be writing an application that interacts with it? Now, if you, for example, imagine you've been asked to write an API that interacts with a popular, or even not so popular system. Okay, I can ask it, and it's now given me a whole bunch of information and helped me already get started. Right? I don't have to kind of guess this. I don't have to trawl through search results. I might get similar information in a search result, but I'm relying on the efficacy of the language model to understand this and give me a curated set of information. And here, I'm kind of like, then one of the kind of the features of these language models is they have like memory. So you can ask refining questions. You can ask it a question like you ask a human, and then you can ask it to drill down. And so, for example, here, I'm asking what questions should I be asking when building applications against GitHub. And so again, it then gives me some more specific information. Now, as a person going into a meeting with the customer, I find this really, really helpful because now I know, and I guess I'm going to sound more knowledgeable than maybe I am. So maybe you could argue it's a bit of smoke and mirrors. I'm not knowledgeable, but I think as a developer, I understand the concepts, and I can then translate that to the customer with my own knowledge, right? So I'm not advocating that you should basically go in not as a developer and use this because you will get found out, right? So I can then drill down, okay? I can actually start to think about, okay, well, now I've got some more information about this requirement. Talk to me about some, not architecture, but some functional and non-functional requirements. Talk to me about things such as security. And you'll see there's two different kind of user interfaces. What I'm showing here is that If I want to be in the AWS console, I can ask the same thing as whether I'm in my Visual Studio IDE. The interface is the same. The information I get is slightly different. Okay. On the right-hand side, okay, I have now got some more information about what the business wants, and I now ask, okay, I'm a Java developer, and I've got this now set of requirements. What are the best ways to deploy this on AWS? So the stuff here has been, the corpus of information has been trained on 17 years worth of documents that we have got, no one else has. So if I want to ask very specific AWS questions, I'll go here. The stuff on the left is using a language model. I don't know which one it is, and we don't actually state because they're changing all the time. But it's a more general model, which means I can ask it broader questions. If I ask this GitHub, it won't have a clue. If I ask this one, it knows about GitHub, it knows about Fortran, it knows about COBOL, it knows about everything that you'd expect a large language model to know. So kind of the takeaway, okay, when I was doing this is that now I have, having never worked with GitHub before, I now understand some of the things I need to think about. I understand how the GitHub API works. I understand how to size my solution. I now have some functional and non-functional requirements, and I can now move on to the design phase. So now I'm going to think about, okay, what are my design choices based on the information and inputs I've already had. And so the first one is, I've already said I'm a Java developer, which I'm not. Okay, I'm not a Java developer, but I'm trying to mimic what a Java developer would do, just because I wanted to see how good it would be. I did Java many, many years ago, and I would never call myself a Java developer. And so I can say, for example, what are the best Java frameworks to use when deploying a solution like this, right? So I know and again, it's got that context, I've already asked it those questions, it knows what questions I've previously asked. I now ask it to recommend some frameworks, and it's come up with some pretty damn good recommendations actually, including the middle one, Spring Boot, which is used by something like 85–90% of all Java developers, according to the Stack Overflow developer survey, if you believe that. But then I can sort of, for example, say, okay, well, it's recommended Spring Boot. Let's now dive deeper. Can you provide me more information about Spring Boot? So what I'm doing, again, I'm using this tool to now give me effectively almost like a checklist, right, of what I need as a developer. And bear in mind, I haven't done Java development since 2003, so a long time. I was able to follow this easily, right? So actually, I mean, I won't spoil the story, but there is a working application at the end of this. Okay, and I can do the same thing back in the AWS land, and I can actually start to say, well, okay, do you understand AWS? Do you understand about Spring Boot? Do you have any opinions on Spring Boot? What are the best ways of deploying this on AWS? And sure enough, it actually has suggestions. So again, what I'm doing is I'm using these tools to help me at the design phase to start to build a better picture of what my options are. Because, you know, one of the pain points I used to find as a developer is that there was too much choice, right? And so how do you go down and narrow down the choice so that you can then focus on actually solving the problem? And then I kind of like ask it some more questions, right? So building my application is only one part of it, okay? I need to deploy it and run it somewhere. So now I can say, well, okay, I've got a Spring Boot. I've decided I'm happy with Spring Boot. I've got some sizing information, right? Give me some options. How am I going to deploy this? And it gives me some options. And I say, well, actually, I'm quite keen on containers. So give me some container solutions. Okay, and then I can say, well, okay, this one looks quite interesting. Now, give me some more information about that specific container solution. So as developers, as a developer now, I am getting a pathway to not only how I'm going to develop my solution, the language and frameworks I'm using, but also now beginning to understand where and how I'm going to deploy this. Which is great because now I'm going to sort of go into development mode. So, first thing, as I've not done this before for a while. Okay, so how can I read this? Okay, so yeah, so first of all, I asked the tool, I need to develop a Spring Boot application that does X, does Y, interacts with GitHub, exposes the REST API. What do I need to do? Okay, and it gives me the beginnings of a recipe. And then I ask it more information. I say, well, that's okay, but it's not enough information for me, who's a lapsed Java developer of 20 years, to actually know what I'm doing. So I ask it then to give me more detailed information. And this is when you start using language like, provide me a step-by-step guide, give me a detailed information, give me code that does this. And it provides you now with specifics on how you actually get started. So that's the first bit. Okay, now I ask it actually to provide me with some working code to do this. So I actually ask it, give me some code that will actually create an API endpoint. And I run it, okay, and when I put it in my IDE, I get an error. And so here, you can't see it, but I can select the code, and I can actually, from the actual IDE, I can just select fix. It sends it to the interface, and the interface looks at it and says, oh yeah, I gave you some bad advice. This is what you need to do. And this is kind of like one of the learnings I found is that the output you get from these tools can often be stupid, but if you ask it again, it then fixes the problem, right? So you almost have to use it, run the code, generate the error, and then ask it to fix it. And this is definitely a set of workflow I've seen that seems to happen a lot with these tools. So it works better in some languages than others. With Python, I see this a lot less. I've done the same flow I've done with Python, and it was just a much easier experience with less backwards and forwards.
Does it send the error as well, or just the code snippet that was broken?
Sorry?
Does it send the error as well as the code to fix, or can it just send the code snippet?
So here, for example, I've just selected the code, but I've got screenshots later on which you should see, because this is warts and all. So this is not a nice story, right? This is not a case of I did this and it worked. This is a case of I did this, I got an error, I got another error, then I got even more errors, and I thought, what's going on, right? So then I show how I approach solving those using the tools. But basically, in this one here, I just try first of all through the actual IDE interface. In further steps further down, I actually use a different approach. But yeah, you can either grab the error messages and ask, I've got this error message, what does it mean? And this is useful because we've got context, right? So it understands what I've done so far. So if I give it an error message, it understands the error message is related to this piece of Java code, which is related to this thing we've asked it to do. So it brings these things together. And also within the IDE, it knows the files you've got, the file tabs you've got open. And so it uses all that information to give you a much more specific answer, which, if you think about it, you just can't do with search, right? You just can't do that. Well, I've never seen a solution that does that with search. So actually, and this is an exact example. So I use the fix to fix the code. The code runs. I run it. It generates an error, right? I copy and paste the error. So here it says, when I try and run the app, I get this error. What's up, right? It then says, oh yeah, sorry, you need this. I put the code in, and voila, I now have my Spring Boot application, which that took me about 25 minutes to do, which I thought was pretty impressive for not having touched Java for 20 years. And Spring Boot on Java 17 is very different. I mean, this is in my Java 1.2 days, we didn't have annotations, we didn't have any of the cool stuff you have now in Java. Actually, who here is a Java developer? No one. Wow. That's unusual. That's unusual. When I speak at events, normally it's the other way around. It's like normally everyone puts their hands up. It's quite interesting. Java is still cool, is what I'm saying, right? Don't be ashamed. Don't be ashamed if you. Even though the code compiled and the code ran, okay, when I went to access the application, I got the dreaded error 500, okay. So I went to the logs, I grabbed the logs, same thing again. What does this mean? Ah, yes, stupid me, I should have told you. This is another limitation, right? What happens is it kind of like is like the person you might recognise at work where, you know, you're struggling, you're a junior developer, and you want some help, and the senior developer goes, oh yeah, you just need to do this. And you kind of think, okay, that's helpful. They don't give you all the details, they give you enough. And so you think, okay, I'll just do that. And of course it doesn't work. And so that's how this works, right? So once you go back, it's like, oh, actually what you need to do is you need to do these things which I didn't tell you to do in the first place, right? And then when I fix that, I now run the application again, and voila, I now have a working API on Spring Boot that grabs the last 10 updated projects from a particular org on GitHub. Voila. So, all good. Now, I don't know about you, but one of the things that always drives me crazy is always the little things when you're writing applications that you need to know. Like, where do I put the configuration property file? How do I configure logging? So here, for example, I'm showing, okay, I really need to configure trace level logging on this Spring Boot application. How do I do it? And there I go. I haven't had to go to Google search. I mean, it has actually gone, I think, oh no, not see, quite often, because we register the sources, quite often the source will be like Stack Overflow, right? So we do attribution, we point people back to the original doc, but now I can put that in there, and I can actually ask it for some specific information, and I now have configurable logging in my application. Now, the code that I produced so far is very rough and ready, no documentation. So one of the things that I ask the Generative AI tool is, can you provide a doc string for this class, right? Because I want to make sure that I leave this code better for the next developer. And so I ask, you know, you can see my class, you can see the file, it's there. Generate a doc string for me. You can understand the code. So I do that, and I paste it in, and it's actually pretty spot on. So now I can really easily now, just for every class I have, I can just generate doc strings in the actual code. So I'm already producing much better code, which is more documented, and it's not been a hassle. So you know, I'm not worried about it. Okay, so what's the next thing I've got to do as a developer? Actually, this is the one I haven't done yet. So I decided that I want to document, because this is an API. I want to document the API with Swagger. So I want it to tell me how to do it, and so it basically tells me how to do it. I haven't done this bit yet, so I just want to show you that, you know, how far you go is up to you. I could then basically take it to the next level and create Swagger APIs. I've been using Git for as more years I can know, but I still don't remember all the command lines, right? So wouldn't it be good if we could take the same AI goodness that we have that I've in these tools and put them on the command line? Well, luckily we can. So what we've done is we've taken the same stuff that we've got in the IDE and the console, and we've put it in the command line as well. So we can run a command called, this is Code Whisperer AI. I then basically say, set up a new Git repo using the current directory. What's the command? Git in it. So I know that, but I wanted to test it. And then I can say, right, okay, look, now add all the files into the local Git repo, git add dot. Right, and I could kind of do things like Git rebasing, you know, Git pushes, or Git forks, Git branching. I can ask this to do it for me, and I don't have to go out the command line to actually do it. And I can actually click on, once I've got the command, I can execute it there, I can tweak it a little bit. So even in the command line, you're not safe away from AI, okay? And actually, for advanced Git, sed, awk work, it's, if you do a lot of stuff in the command line, it's amazing. So we've got our application, but we now have to make sure that it works to the satisfaction of the QA team. So this typically involves, creating the unit tests if you haven't already done them, doing security scanning of some kind, and then maybe doing integration and load testing. So here I ask it, I think if I can't really read, can you create a unit test from the code? And it does, it creates a unit test. I have to refine the question and ask it to give me some additional information that's missing. And then I can, that is the unit test. So basically I now have a unit test. I don't actually show it running. It says tests running there, but so I now have a unit test. All I've done is ask it, because it knows the files I've got open, build me a unit test for this. I actually found it, because I wasn't used to Java for such a long time. This was the hardest thing for me to understand how Spring Boot did the unit tests. So I probably spent maybe about an hour on this. So this actually was the biggest part of the time I spent, is actually just trying to figure out how this works. And actually it wasn't even writing the unit test, it was actually how do I run the test? How does it work when I actually do my full build? I use the tools to help me, guide me, but it's weird that I spent more time on the test. So I've got my code. Let's run a security test. Okay, so speed up your alley. I use a thing we have which is built in that scans the code. And this, I didn't know this was going to happen. You can't really read it, but the code has a CWE 352, a cross-site forgery request. Very common, and it's where people can effectively intercept your HTTP requests, modify the payload, and give you some nasty surprises. So I can actually now ask, do I need to be worried? Is this a big problem? Even because it comes up as a high severity. So from not knowing anything about this, I can actually get more information. I can drill down. I can ask, can you provide some fixes for me? And then I can actually make those fixes myself. Or what I can do is I can actually use the tool itself. Okay, so this is actually what it looks like when it's expanded. And I think I've got a screenshot where it says actually fix it. No, it's not that one. Is it here? Yeah. So here on this one, I've got a little button here that says fix. So when I fix it, I then rerun the security scan, and it says now I've got 0 security issues. So this is now helping me to do my security scanning. It detects. So under the covers, we're using an AWS service called Code Guru, which is the one we use actually at Amazon to test all our code for security vulnerability. So it's pretty solid. But obviously, like all of these tools, right, it's only a starter, right? All code has bugs, so you need to be continuously testing these things. And then I want to now do some load testing. So I'm not sure how familiar you all are with tools like AB, Artillery, Hey. These are command line tools that are very simple. You run them from the command line, hit them against an API or an endpoint, and then it just gives you very simple results. So again, I'm using the AI command line tools to remind me what the parameters are to use these tools, because I never remember these, right? And actually, I don't ever need to do it anymore, because these tools will do a far better job than me. And you can see here that I run it, I try and run it, I realise I don't have it installed, I then ask it for me to how to install it, it installs it for me, then I run it. So if you don't have the tool, you can even ask it, how do I install this tool? So testing is good, right? The next part is the deployment stage of how so I'm just thinking actually, so time-wise, what time was I supposed to finish?
A while ago.
Oh, was I? Okay. Well, okay. I'm gonna. This first thing I'm going to finish up now anyway.
Okay.
So from the deployment perspective, okay, we now need to actually make sure this thing runs, right? We know it runs in the IDE, but how do we actually package this thing up so that we can give it to other people to run? So here we can actually ask, well, okay, tell me how to package this application. So here it now tells me how to run Maven package run, and I now have a working application. I can then also ask it, okay, well, I've got it working now, and I know from the beginning of this I wanted to deploy it on a container solution, and the solution was based on the information I gave it, ECS. Tell me the steps I need to follow. So I can use prompts like, give me a high-level overview of what I need to do, right? To make it simple for me, so I don't have to go and remember 20 different steps, which a lot of the time these things require. And when I read this, basically it's like package application, upload to container registry, and then deploy. Simple, right? So I go through the process. First of all, I ask, how do I package this up? First of all, do AWS have a Java distribution? We do, Amazon Corretto. How do I build a Docker file with that? Here you go. Give me a sample Docker file. There you go. That's it. It knows everything I've got, and I've now built my container image. But when I do it, it doesn't work. And it doesn't work because it provides some generic information about the location of my compiled jar file. I give it the error, and then it says, oh yeah, sorry, you need to actually put target, not bin. So again, I'm using the troubleshooting to help me figure out problems. And then I say, well, you know what, I don't use Docker anymore. I gave it up this year. I now use Finch instead. I said, oh, I want to use Finch instead of Docker to build my containers. Tell me how to do it with Finch. And it tells me how to do it. So happy days. And when I go through the process of packaging up my container, testing it out, and then I now have the same application running in a container, all good. Now I want to basically start creating infrastructure as code, and now here I'm switching to a different generative AI called Bedrock, and you can't read this because it's really tiny. But basically I say, you know, I've got this Docker file, this Spring Boot application. I want you, give me the command line options to upload this to a container registry and follow those steps. And so I follow those steps, and I end up with now a container image. So the first 2 steps of the 3-step program is complete. I've packaged up as an image, I've uploaded it to a container repository. And then the next thing, is I want to use infrastructure as code to deploy this onto AWS because I don't want to touch this manually. So how do I do that? Give me a sample CloudFormation template. There we go. All I have to do is update my container image from the previous step, and then I deploy it. But when I deploy it, it gets an error, so I put the error back in here. You're getting the kind of gist of this, right? It's back and forth, and then I fix it. Get sort of another error. This time it's just a command line switch that I've missed. And then I deploy it, CloudFormation does its business, and about 15 minutes later I now have my application running in the cloud, and it's all been done through infrastructure as code. So almost done, right? Almost done, except for when I actually go to run it, I realise that the logs are generating this error, and I realise what the error is because Macs are running on ARM processors. We support ARM processors on AWS, but you have to specify ARM processor. And so I've got an ARM binary running on an x86 Linux virtual machine. So obviously Java's not happy. So I then say, oh, can you tell me what I need to change? It tells me what I need to change. I redeploy, and it works. So almost there. Now what I need to do, my project's finished. I am going to write a README in the repo that tells and explains what this code does, how to run it, and I literally just type create a README based on the files in this repo, and this is what it produces. It's pretty amazing, actually, I've got to say. I now no longer have to do any documentation, if that wasn't enough, you can actually now, this is a point to a blog post, you can actually use Generative AI to create things like UML diagrams for your Java applications, architecture diagrams for your infrastructure, the work. So this is still evolving very, very quickly, but that's kind of where we are. So I'm going to stop here. because I've been speaking for a long time, but I think that that's kind of the end of the kind of the deployment cycle, right? So all through those steps, through all the different parts of the SDLC, I've tried to show how I'm using these tools to help me, and it's like kind of the observations I've made is I've not had to go out of the tooling that I'm using for development. I've not used search. I've got everything within the context of development, and so it seems really easy. And this is something that I've not touched for 20 years, right? If it was something I was more familiar with, I would imagine that a lot of the errors I found would have probably been something, oh, you know what, that's not an issue. I kind of fix that by default. In fact, actually, when I did this with Python, because I'm very familiar with Python, I could see there's some mistakes made, so I just fixed them as I was pasting the code into the IDE. So that's the first bit. I was going to I think we have a break, don't we? That's a break. Is that right? Is there a break? There isn't a break. Okay. I guess because we've overrun, so probably not going to be able to. Okay. So what do I do? I mean, I can stop.
I think we're probably going to have to. Is this the point that we can stop?
So there's a few more bits and pieces, but only 5 minutes.
Okay, yeah. I think probably what we'll have to do is to do that and then do a Q&A.
So the best bits are the learning bits, right?
Yeah, I'll see. If anyone needs a toilet, yeah. Sorry.
Yeah. I'll wait a few minutes before I do this, because this is probably the summary of what I've learned.
Yeah. Annoyingly, we're not going to ask for the demo.
Sorry? It's okay.
Sorry, all of that getting it ready.
No. I mean, I needed to do it anyway, so
okay.
No, it's fine. Yeah.
Not many amount of people need to pay, by the way. It's usually me, so it's quite nice it's not for a change.
Yeah. Yeah.
Of course you do.
When you create the container images, and the tool creates the images, how bloated are those images? How much is it bringing in from?
So the question is, how bloated are container images that you're bringing in? So it depends on the Docker file you're using and the mechanism you're using it. There are tricks to optimizing the image. Also, I would say be wary of skinny images, because they may also be hiding things. So I only ever used authorized signed images as my base images. So they can be slimline, but they tend to be more. They're not like Alpine Linux skinny type things, which are really small, right? In the example I gave, I'm using a very, very, I would say, bloated approach. You could, if I asked it, can you create an optimized container image Docker file? It would tell me how to do it. So it would basically use like the build as piece in Docker that allows you to reduce all your build stages to one and compress all the layers. So I'm not doing that. So I'm basically having multiple layers. So you can use it, but for this particular demo it wasn't really needed.
So my concern would be whether there's any CVs amongst those records.
The testing that I showed. So the question was, you'd be worried about CVEs in the container images themselves. So first of all, the baseline container images themselves are sanitized, right? And they're read-only, right? So if you're pulling from a base image that's been scanned already, you're reducing your attack surface and you're reducing your risks, right? Yeah, totally. That's what Docker, Docker allows you to do that. But when you push in the steps there, I pushed the local Docker image to ECR. There's a Docker scan option, and we use a number of different tools. So we use Trivy and Anshore as well. And you can scan the image as well, again, if you want. I mean, it's not going to give you anything else because the base image is already scanned. My code has been scanned and shown okay. And there's nothing else that gets in the middle, right? So you could, if you wanted to, go that way, but that's not needed in this situation. If you were doing a CI/CD pipeline, you would always, as a final output, do a security scan of your image as a final report. Right. One person what? Okay.
At my age, I can't rush that side of things.
So well, I don't mind. This is, you know, I mean, they might have left. I'm not in a hurry, so no, I'm not in a hurry, so I'll leave it to you to decide. Right. So this is literally this is only going to take 2 or 3 minutes before questions, right? So So one of the things that I've learned, okay, so I've tried to condense it into three points, right? Because these generative AI tools are good, but you know what? If you're a developer, your job is very, very safe. I mean, very safe. These are no way ever going to take our jobs away, period. And I will stake my reputation on it, okay? But they are incredibly powerful if you know and learn how to use them. And if you think about the evolution of tooling, you know, when people were getting used to the IDEs, for example, every evolution of tooling has been a difficult period where people haven't really kind of like used it until they've had that brain, that penny drop moment where they've realised that suddenly my life is so much easier. So, how to get the most of it, right? The first thing is I showed at least 4 different generative AI tools. I showed the stuff in the IDE, the stuff in the AWS console, the command line, and I showed a thing called Bedrock, which is our ChatGPT equivalent, right? They all have different models that sit underneath them. They all are trained on different data. They all have different modalities. And what that means is that they'll have different context windows, which is the amount of information you can upload to them. Some of them are designed to be very sensitive to latency, so they want to give you straight away a response. Others, it's like a bit more chilled out. You know, I'll give you the right answer after I've mulled it over. And so it's important when you're asking or wanting to use it to get something, make sure you know which tool is the right thing. So if I'm asking an AWS question, I'm going to use the AWS Q builder in the console because it's got all the AWS trained material. If I'm going to want to know about how to interact with GitHub, I'm not going to use it because it's going to have a clue. So I'll use the one in the IDE or I'll use Bedrock. They'll both be as good as each other. So make sure you're using the right tool, the right generative AI tool for the task. There are multiple out there. And so this is not a case of, you know, you can just sit back and let ChatGPT, for example, do all these. It may work, but my experience, I mean, I started on ChatGPT and then moved on to other ones, and it's still a good experience. But I find that when I'm using more specific tools, I get better output and better responses. The second one, which I see a lot actually, and I think this is where certainly when I'm working with customers overseas, the temptation is to use the prompt as a replacement for the Google search bar. And so I kid you not, I will see people just type in like 1 or 2 words, like, you know, Spring Boot or GitHub API, and that's all they put in there, right? And of course they'll get junk. I mean, they won't get junk. They'll get, you know, whatever the language model decides it's going to give you, right? These are non-deterministic tools. You'll never get the same response twice. Okay, so you have to be very specific. And here, talking to it as if you were talking to your children is where your parenting skills, if you've got kids, will really come into their own, right? You have to sometimes be verbose. So in some of my prompts, for example, I will say, I want to write a Spring Boot application. I'm a Java developer. I want you to produce all the output in YAML, not JSON. I want to use etc., etc. I will be very specific, and that means that when I get results back, it will be more inclined. In fact, this works for all generative AI tools as well. And then the final one is context. Large language models all work by providing context. So, and different models have different capacities. And different tools will automatically get context from different things. So in the examples that I've been using, the files open in my IDE are automatically provided as context. If I have no files open, that's less context, which means I'm going to get a poorer response. If I have one file open, the main Java class I'm working on, the context is going to be focused on just that Java class. So if I want to write a unit test, I'll have that one file open and say, write me a unit test for this class. It knows exactly which class I'm talking about. So understanding for the tool you're using, the context and how to build the context is really important so that you get more specific, opinionated information for what you want, okay? So this is what I've learned, okay? These are the 3 keys that I found that helped me get from, you know, it's okay to, you know what, this is pretty damn good. And then getting consistency, trying it over and over again and getting better at that is then where you really start to kind of get better. There are some gotchas as well, right? When you're working with libraries, and this is definitely what I found with Java. So I implemented Spring Security. My God, that was a rabbit hole I thought I was never going to get out of. Which version of Spring Security was I using? There's 5, there's 6, there's even 7 now, right? Large language models are trained. It takes some weeks, costs millions of pounds to create these things. They don't always have the latest versions of these libraries. So the large language model will probably give you what it thinks is the right one. So you have to be very specific. So I want Spring Boot version 6. Give me the API that works for that. But often, if you're using something very, very new, it's not going to work. So there are some workarounds. So this is where you would switch out to a different tool like Bedrock. You would, for example, copy and paste some API documents of the new version, put that as context, saying this is the latest version. How would I write an API using this version? And then then it actually works. So even though the large language model doesn't know and wasn't trained on it, you can still effectively feed it that information. It's more work, but this is how you can work around it. The other gotcha is that sometimes I can use words and I can get pretty average output. I switch the words, I remove certain words, and I get way better, right? I've had to actually, it's really strange, I've had to stop saying please and thank you. I was always writing please and thank you for my prompts, and it was actually affecting the quality of my output. So it actually doesn't like people being polite, is the takeaway I had for that, which I thought was quite interesting. Being super explicit in what you want and direct is key, but then with the previous point, okay, it's not being short, okay? If you provide short inputs, you'll get rubbish out. And this is where probably this is why Google search is so good, right? You type in just a string and it will give you a whole bunch of information. These large language models do not work the same way in that respect. And you'll get poor output. And there's 2 3s. Look, I didn't verify that. I didn't verify that. So whilst the output of these tools is useful, right? I would never ever use them without going through, first of all, as a human being and testing the code myself. And I think that's just common sense at the moment, right? So treat it as, maybe a developer that's just joined your team. You've asked them to do something, they've created it and you're reviewing it. Treat it like that, rather than the most experienced person in the team. This person has written the code, it's gospel. You're going to end up in a world of pain if you do that, right? And which is why I can confidently say our jobs are safe, right? These tools will not help unfortunately, people replace developers. We still need the skills we have because there's still so many holes and blanks. These tools just simply don't know how to deal with, right? Which is a good thing, right? And so what actually, the way that I kind of like it is, rather than the craft of development being reimagined, it's actually the craft of development being recalibrated. And there's a really good blog post by this chap, Kent Beck, who's, if you like development and sort of futures, his blog is amazing. And so this is shamelessly pinched from him because I think it's the best mental model I've seen, is that there are going to be a bunch of stuff that as developers we no longer need to think about, and the AI will do way better than us, right? There's some stuff in the middle that it's going to help us with, and there's a lot of stuff that it just won't have a clue, and we will still be at the heart of it. Okay, and so the way that I like to think of this is that, you know, generative AI, like all the other tools, is just another tool in our toolbox, and rather than being artificial intelligence, it's more assisted intelligence, right? Pair programmer perspective. So that's pretty much the talk. So you've got a link to the presentation. So the code that I've been creating from this is in a repo, which you can do what you want with. And I write in this blog post for my company about this stuff and other stuff as well. So I think I'm going to open up to questions now. But yeah, so. If anyone has any questions. Oh, sorry.
I know in the beginning when this all came out, they were saying about privacy, like don't put in work code, or like if you've got an idea for a startup, don't put that in case someone else pops in it. So like, how is that? Is that got better?
So that's a very good question. So the question was, how do you think about privacy when working with these generative AI tools, right? Do you leak your top secret stuff? So this is where all the generative AI tools out there are different, and they're not all as privacy preserving or respecting as each other, right? So absolutely. I mean, I've given these tools to my kids and my wife. I don't think there's anything too secret that we're doing that I have to worry about. I would definitely not do any work-related stuff on ChatGPT, but I'm happy to do it on the Q stuff because I know how it works under the covers from a privacy perspective. So I think what I would say is that what you should do is check, right, what is the privacy position of the generative AI tool. Ask questions such as, how are you using my data? Are you using it at all? Are you using it to train the model? And normally what I find when I've looked at a few of these, there's a trade-off by giving you access to something for free, but we're going to use your data. Sorry, but we are, right? Whereas we don't do that. We don't use your data. We use some of the telemetrics. So opt out, if you like a good response, up, down, that kind of thing. But you can opt out of it as well. So the tooling lets you to opt out of that as well. So ask that. Okay, you know, how is your data being used? Can you opt out? Do they have a responsible AI kind of like policy? What is it? Can you see it? That kind of thing when you're using these tools, because I think that's what differentiates the players at the moment. And it's a really interesting topic because I was at an event last year and I think ChatGPT on Azure, they have the same thing, but they have like a different flavour of it. And they said that basically they have got all these guardrails like what we do, and it was interesting because it really divided the audience as to whether that was a good or bad thing, because what they said is that, you know, if we use ChatGPT on Azure, then you control the guardrails and we don't know. So it's a black box. We don't know, you know, what the rules are, what's being censored, what's not being censored, that kind of thing. So I think that's an interesting conversation that I'm hearing about at the moment. And so I work in open source, right? So my view, and there's no definition of open source and AI at the moment. We're still trying to figure that out. But the feeling is that open source helps solve that problem because then everyone can see what's going on. But the problem is the governments and regulators don't like the thought that everyone can have these tools. because they think they're dangerous. So this is the current power play that's happening in governments around Europe and America at the moment.
I'm a bit annoyed by the generative word.
You're annoyed by the generative word?
No, I like the generative word, but I'm annoyed by the way that has been used. It's used like a buzzword. It's like, oh, generative. So I understand that there are large language models that can be little or big, like 100 megabytes, gigabytes, or a few megabytes, doesn't matter. These are LLM. So everything we get out of it is just what is already there, so it's not generative at all. So what do you think about this, the use of generative,
So
whenever we talk about AI?
So the question here is the use of the word generative AI appropriate when we describe these tools? I actually disagree with you on this one. I have a different slide which I'll show you and why. This because I've got the wrong glasses now, so this is where I hopefully. Where is it? This one here. So this is the reason why I disagree with you. If this comes up. So generative AI is just an evolution of the other types of AI we have, right? So whether it, convolutional networks, deep learning, all that kind of stuff. And effectively, the way that's different is if you look at other AIs we have today, they take inputs and they give you a probabilistic response out. So I've got a transaction coming in. I'm going to give you an opinion, right, based on a probability of whether this is fraudulent or not. It's not creating anything new, okay? It's actually just giving you its feeling, right? How confident it is that this is one or the other. With these models, these large language models, they are actually creating something net new that wasn't there before. So the word generative, I think for me, that makes sense, right? Because they are generating new things. They're generating new images, they're generating new videos, they're generating code, right? So it is absolutely the right word to describe as an overall what these things do. Because remember, this is not all AI, this is a subset of AI. So when we talk about large language models, okay, large language models are what underpin generative AI. I mean, they're used for other things as well, right? But in this particular case, we're using them to create, in the examples I've shown, new code. But my wife uses it to create lesson plans. She's a teacher, right? My son uses it to create music lyrics because he likes music. And this is something you couldn't do with deep learning networks. The traditional, either reinforcement learning, sort of deep neural networks. They don't give you that same creative new output, right? So that's my view, right? I'm not sure what you think about that.
Probably got time for one more question. Is that cool? Yeah. You pick.
I got one more question. So, do you know whether the big large language models players like ChatGPT, Amazon one or Google one are using our prompts to relearn the same large language model? So, is that our prompts learning the one big model which is served to everyone else?
So similar to the other question, right? Which is, if you're using prompts, if you're prompting using these tools, how is your prompt being used? How are they using that information, right? So that comes down to the privacy policy of the generative AI. So I know that we don't use those, okay? And when I use other ones, I always check how that is, and I'm comfortable with my prompts being used by them to improve their language models, because that's the payoff I get for you being able to use it for free or very limited money, right? A lot of these AI companies now, they will have a pricing model where you give them some money and then you can opt out of that.
So my question according to that is that if I use a free product, that's chances are it's going to be using the data I'm putting that.
It depends on it depends.
Chances
But yes,
are, yes.
in the same way that when you use social media, they're using your data. So it's no different.
Absolutely, yeah. And then my question about that is that data feed to the one big master model, which the rest of the things are, or they are like sub-smaller models which are integrated into the model?
So that's an interesting question. So I've not personally seen that. The only time where I've seen prompts being used is when a model's been trained, because these things take like days or weeks to train, right? And to do A/B testing, so you have model 1, model 2, you have a set of like 100,000 prompts. You input the prompts into the model. You assess the output, okay, and against version 1 and version 2 models. You actually use generative AI to assess the variance between the two, as well as other algorithms. And then if they're very different, and you can, the tools can tell you whether they're improved or not, then you know that you've got either improvements or not. So that's the only time I've seen those used. Whether those prompts have come from people or not, I don't know. So yeah, I mean, I'm not the way that we look at these language models. There's three layers, right? The stuff at the bottom is the compute, memory, infrastructure, storage, all that kind of stuff. The bit in the middle are and this is actually where all the training happens with the models. Then the bit in the middle is like kind of the actual the Titans, Anthropics, the Claudes. This is where the actual large language models themselves, which you can build applications to use, and then on top of that, you've got the kind of the SAS type things that interact with the layer 2, right? So I've not seen the prompts myself used further down, right? They tend to focus more on what I'm seeing at the moment is this kind of battle to try and either on data providers monetize their data, and on the model trainers trying to figure out how to get the right data and clean the right data, because you know, in the early days, because I've been using ChatGPT for a while, the quality of the responses is quite poor, because they're literally training on billions of documents, right? And you can't, there's no way that you can train or review all those, right? So a lot of the focus now is on creating ways to actually improve the data you actually have to train the model. Right. Well, thank you.